Hello everyone, welcome to my channel. This is Leo, and let's do some more Leetcode problems today. So today's problem is called combination sum. We were given an array of distinct integers candidates and a target integer target. Return a list of unique combinations of candidates where the chosen number sum to target. You may return the combinations in any order, so the order doesn't really matter. And the same number may be chosen from candidates an unlimited number of times, which means we can reuse every element in this candidates array. And two combinations are unique if the frequency of at least one of the chosen number is different. So that means if we have like 2 and 4, we can use two 2s and one 4, and they will be thought as different. So yeah, there's some restrictions here. Let's take a look at the example here. So we have the candidates 2, 3, 6, 7, and the target is 7. Of course, we have a 7 over here, and we can have two 2s and a 3 to make another 7. That's why our output is like this. And 2, 3, 5, we got 8. We can do 4 2s, 1 2 with 2 3s, and 1 3, 1 5. Okay, and if it cannot form any target, we can just simply return an empty array, empty list. Okay, so this looks like the combination problem to me. So we can try from the first element of the candidates and all the way down to the last. If not working, we can go from the next one. Okay, so that sounds like a backtracking problem. So let's form a answer, which is a new array list, and for each answer that we're going to add into the final answer, there will be a container for it. So I will have another container here, and now we can call our backtrack problem. So what do we need? We of course need to start from the very beginning. First we need the answers to construct, and we need the first element in the candidates array, and we need the candidates, and we need the target. Okay, and after the process, after this function call, we can return the result. And how do we write the backtrack function? So backtrack, it should be a list of integers result, and a list of integer cur to contain all the elements, all the results from each level, each iteration. And we still need a index that marks the start of this iteration. And we will need the candidates and the target. So instead of calling it the target, I'm going to call it remain. Okay, so when do we end our backtracking the function? So that's when the remain equals to 0. Now we know that we are reaching a solution, so we're going to add it to our final result. So we are going to add a deep copy of the current result to our final result. Okay, and else if remain is less than 0, which means we have like we have 5 here, right? But if adding this 5, we'll get 10, which exceeds the target. That makes the remain less than 0. So we'll simply return. Okay, and how do we do the backtracking? We start from the current index and go all the way to the other elements in candidates and see if we add it, what will we get for the next iteration. Okay, so for index, starting from index, and candidates.length, first we will add the current number. So cur.add candidates I, and we will call the backtracking for the next step, and also it's going to be step result cur, and so the current index is I, and candidates, it doesn't really matter, and remain minus candidates I. That's the target that's left for the next iteration. Okay, and after this call being made, we have to remove what we have right now. Okay, so when it goes down to the end, when remain is equal to 0, we got our answer, and it automatically returns, and we remove it, we start our next iteration. That looks pretty good. Let's run it. Okay, I think it passed the test cases. Let's submit it. Needs some time to run. Okay, accepted. And that's pretty much what we have to say today. And yeah, the last thing is to analyze the complexities. So this is a tough work for this solution. So the time complexity is the n by target divided by m, which is the minimum value in candidates, plus 1. Okay, and the space complexity is going to be target divided by the minimum value. All right, thank you so much for watching, and I will see you in our next video.